Good morning, dear student. I am Shivraj Singh, Assistant Professor in Electronics and Communication Department. Today, I will discuss about the antenna parameter. These are the different antenna parameter like radiation resistance, radiation pattern, radiation low, beam width, antenna bandwidth, radiation intensity, directivity, other than antenna polarization, directive gain. Right? These are the different parameters in which define or specify the any antenna. So first will be discuss about the radiation resistance. So as we know that the antenna is a metallic rod, which metallic rod that transmit the electromagnetic wave. That means antenna is a device which convert the radio frequency into a electromagnetic wave, which is electromagnetic wave, right? The electric field and magnetic field are just perpendicular to each other, and the propagation of wave perpendicular are these two. So here we know that the antenna is a radiating device in which the power transmitted into a space in the form of electromagnetic wave. The total power radiated by an antenna is given by W equal to current RMS current per square into RR. So here the RR represent the radiation resistance. With the help of this equation, we can calculate the radiation resistance. That means RR equal to the total radiated power upon current ka square. Right? The total radiated power is the combination of radiated power plus loss power. So here total radiated power W equal to P radiated power plus loss power. Next one is the radiation pattern. So basically, radiation pattern is the graphical representation of the antenna radiation property as a function of direction or as a function of space coordinate. That means here we basically antenna radiation property. That means uh, these are the power, flux density, radiation intensity, field strength, directivity, polarization, beam width, bandwidth. These are the basically antenna property. Right? There are two type of pattern. First one is the field pattern, or second is the power pattern. Field pattern, a trace of received power in terms of electric field or magnetic field at a constant radius is called as a amplitude field pattern. If we draw the graph between the electric field as well as magnetic field in the with respect to direction, that is called field pattern. Next one is the power pattern. If the graph plot between the power density along a constant radius is with respect to direction is called as a power pattern. So basically, here in this diagram, so that this one is the field pattern, this one is the power pattern. Next one, normalized field pattern. The normalized field pattern is defined by the maximum value maximum divided by the field pattern component, which is divided by its maximum value. The ideal value of normalized field pattern is the unity. It is a dimensionless quantity. So according to definition of normalized field pattern, E, theta equal to E theta theta phi upon E theta की maximum value. E represent the electric field component and E theta max represent the maximum value of the electric field component. Next one, principal plane. The principal plane are used to describe the performance of the antenna, which is divided here, classified into two types. First one, the E-plane pattern, or second one, H-plane pattern. So basically, E-plane pattern is defined as the plane containing the electric field vector in the direction of maximum radiation, and the H-plane pattern, that is magnetic field plane pattern. Here, H-plane pattern is defined as the plane containing magnetic field vector in the direction of maximum radiation. So here in this diagram, the radiation pattern, the electric, so the radiation pattern. So here the vertical line represents the E-plane pattern, or the horizontal line represents the H-plane pattern. Next one, different type of antenna pattern. So there are three type of pattern. Like first one isotropic, second one directional pattern, or last one omnidirectional pattern. So isotropic pattern are those patterns which radiate the energy in all direction equally. If the antenna or source radiate the energy equally in all directions, that is called isotropic pattern. So best example for isotropic pattern are point source. Next one, directional pattern. Directional pattern are those patterns in which the energy or signal transmitted in the desired direction only. So this is the best example for the directional antenna are the Yagi-Uda antenna. Next one, the omnidirectional pattern. Omnidirectional pattern. In the omnidirectional pattern, the energy are transmitted in a plane. So in this diagram, so the isotropic radiator or pattern. This one, the omnidirectional pattern. Here we can consider a plane, or in this case, we consider the direction, that means r theta phi. So it radiates equally in all directions. For omnidirectional pattern, the energy are radiated in a plane. For example, we can transmit the energy in x by plane. The radiation pattern so in this diagram like this one. If the radiation or energy are transmitted in a particular direction, that means this diagram, in this radiation pattern diagram, represent the only we can transmit or receive only a specified direction. Next one is the radiation lobe. Radiation lobe are the different part of the radiation pattern. If any antenna has its radiation pattern in which has the different lobe. So the different lobe are known as a radiation lobe. So there are different types of lobe: major lobe, minor lobe, side lobe, back lobe, which is represented in this diagram. So here, in the desired direction, we can uh, uh, measure the major direction. Basically, the main beam, the major lobe, is the radiation lobe in the direction of maximum radiation. Minor lobe, any radiation lobe other than the main lobe. That or minor lobe are divided in two parts. The first one, side lobe, and the back lobe. The side lobe, a radiation lobe in the any direction other than the of the intended radiation. Back lobe, the radiation lobe opposite to the major or main lobe, that is called back lobe. In the previous diagram, here the in the desired direction, this lobe appear in here. This lobe are called major lobe. Opposite of this lobe are called back lobe, and these are the side lobe or minor lobe. Next one was the beamwidth. So beamwidth basically uh, are used to measure the directivity of antenna. It is defined as the angular width of the major lobe between the two direction of maximum power is the twice radiated or received power. Basically, the beamwidth is inversely proportional to the directivity. There are two factors which affect the beamwidth. First one, the wavelength, or second one, the shape of the radiation pattern. There are two type of beamwidth appear in the radiation beam. First one is the half power beamwidth. Second one is the first null beamwidth. The half power beamwidth are calculated in the main or major direction of the lobe at the half power point, and the first null beamwidth is measured in the major or main beam in which the first side lobe are appear in the either direction. That is also known as a null point. In the previous diagram, in this diagram, if we can see that the power, so basically radiation pattern are plot in the normalized form. So the maximum value of in this is this point, there is 1, the normalized value of 1 power. At the half power point, that is 0.5, we can measure the half power point. And the first null, that is here the side lobe or in the first null. The beamwidth between this null are known as first null beamwidth. Next one is the bandwidth. So bandwidth, basically antenna bandwidth or bandwidth, it is the range of frequency for which antenna maintain a certain specified characteristics, like a radiation lobe, front to back ratio, and beam width, polarization, etc. These are the specific characteristics in which the antenna maintain in this range. So basically, bandwidth equal to the range of frequency. Radiation intensity. Radiation intensity is defined as the total radiated power per solid angle, in which basically the mathematical formula of the radiation intensity is given by this one. That means total radiated power is equal to the surface integral of the average power into the area. That means ds. Or for in the radial direction, the power is given by ds equal to r square sine theta 3 theta d. So total radiated power equal to phi by lie between 0 to 2 pi and theta lie between 0 to pi. So that means total radiated power equal to the average power, surface integral of the average power, and r square sine theta d theta d. So here, according to this formula, the radiation intensity equal to the average power into r square. That is, this term are known as radiation intensity. Also, the average radiation intensity is given by this formula. That means average radiation intensity equal to the radiated power upon 4 pi. Next one is the directivity. It is the ratio of the radiation intensity in a given direction from an antenna to the radiation intensity averaged over all directions. That means it is the ratio of maximum radiation intensity upon average radiation intensity. Mathematically, the radiation intensity is given by 4 pi into radiation intensity upon total radiated power. Okay. Thank you, class. Next class, I will discuss about the radiation from the short dipole antenna.